I'm recording. Okay, folks, so we're going to go ahead and fill in the note sheet for matter. And here are the notes. These are the things that you need to know. Number one, chemistry. This is the chemistry section of physical science. And so let's talk about what chemistry actually is. Chemistry is the study of the composition, structure, and properties of matter, the processes that matter undergoes, and the energy changes that accompany these processes. So basically what we're going to talk about in this section is the actual properties of matter, the phases of matter, and phase changes. So that's what you're going to be studying. Okay, what is matter? Okay, matter is anything with mass and volume. Or you may have heard the definition, anything that has mass and takes up space, because takes up space means volume, right? So that's your definition of matter. Make sure you have a good working definition of matter. Okay? The kinetic theory of matter. You should find a place on your note sheet that says kinetic theory of matter. This is super important, and the wording of it is important because you have to know this kinetic theory of matter. It's a scientific theory. All matter is made up of tiny particles that have energy and are in constant motion. Okay? So all matter is made up of tiny particles, okay, that have energy and are in constant motion. Constant motion. Now, what are the four phases of matter? Okay, we have four phases of matter that we have to know: solid, liquid, gas, and plasma. Okay, now most of us are fairly familiar with solids, liquids, and gases, right? Plasma is the one that we struggle a little bit with. Okay, and we're going to talk just a second about what plasma is. Plasma is actually very abundant in the universe, but we find it in things like the sun and stars, so it's not as common in our everyday life as solid, liquid, and gas. All right, so if we look at this graphic right here for solids, liquids, and gases, we notice that solids have a definite shape and volume, okay? Liquids have a definite volume, but they take the shape of their container. And gases have whatever volume and shape that the container allows. So it takes up all the available space. Okay? So be sure when you look at a graphic of the solid, liquid, and gas that you could identify which was the solid, which was the liquid, and which was the gas. Okay? Now, what did we say about the solid? We said that the solid has definite shape and definite volume, meaning that no matter what size the container that the solid matter is in, it will hold its shape and have a fixed volume. Okay? Two characteristics of liquid would be they take the shape of the container, right? Take the shape of the container, but they have a fixed volume, right? So the volume doesn't change, right? If you have like 50 liters, you have 50 liters. But the shape of it will change depending on if you put it in a wide, flat bowl or if you put it in a skinny cylinder, right? Because liquids will take the shape of whatever container that they're in. Then two characteristics that we need to know for gas is that they take the shape of the container and they also take the volume of the container. So depending on how large the container is, that will be the volume of gas that you have. So I might have a 50 gallon drum and I put a gas in it. It will take up the entire 50 gallons. But I may pour that into a half drum or something a little bit smaller, and that gas will compress and to fit into whatever container I put it in. So gas takes the shape of the container. It has no definite volume and no definite shape. Liquid takes the shape of the container but has a fixed volume. So it has a definite volume and no definite shape. Solids have a definite volume and a definite shape. Those things do not change with container. Okay? Uh-oh, my image just got too big. All right, so let's talk about crystalline solids. Crystalline solids, okay? Most solids are crystalline solids. That means that the particles are arranged in crystals. You have a lattice-like structure under a microscope. Now, this is not something you would see necessarily looking at the table that you're sitting at, but if you were to look at those structures and the molecules under a microscope, you would see that it probably takes up one of these shapes right here. One of these shapes right here. Okay, so these are going to be your crystalline solids, which are most of your solids. Okay? All right, the next one is amorphous solids. Amorphous solids, okay? These amorphous, the word amorphous means having no form. So these solids appear to be solids, but they don't set up in crystals, right? So they don't have that lattice-like structure. And examples of amorphous solids or non-crystalline solids would be wax, glass, plastics, things that are solids but can be shaped or molded, okay? Anybody have braces? Okay, and they give you wax, right, for your braces, and it is a solid, but can't you mold it however you want it? Okay, so that would be an example of an amorphous solid. Amorphous solid. All right, what about gas pressure? So, you know, we talked about gases take up the shape of the container, right? They fill the entire container, okay? Well, if we take this a set volume of gas and we put it in a large container, then the pressure is very low because the gas molecules have lots of room to move, right? We take that same volume of gas and we put it in a smaller container, what's going to happen to it? The pressure is going to increase because now the same number of gas molecules are crammed into a smaller space, right? So pressure has to do with the amount of contact or the amount of force that's being exerted on the sides of the container. The sides of the container. If you picture a balloon and you just blow up that balloon a little bit, the pressure is not very high. But if you continue to blow that balloon up, what happens to the surface? The force exerted on it is greater. If you blow the balloon up too much, it will pop, right? Because the pressure has exceeded the limit of what that surface can handle, right? So be sure you have a good working knowledge of gas pressure or pressure in general. Okay? What are phase changes? What are phase changes? A lot of times we talk about matter in terms of states of matter, okay, states of matter, but we need to understand that states of matter and phases of matter are the same. So when we say states of matter, solid, liquid, gas, or plasma, we can also say phases of matter, solid, liquid, gas, or plasma. And that's important because when we talk about changing phases, we talk about phases, not changing states, changing phases or phase changes. Now, today in the lab, we actually went through two phase changes. We went from solid to liquid and then from liquid to gas, right? So what is melting? Melting is when you go from what? Solid to liquid. So you need to write on your notes that melting is solid to liquid, okay? What is freezing? Freezing is liquid to solid. So you need to write in your notes that freezing is from liquid to solid. How about vaporization? Liquid to gas. Yeah, liquid to gas. And we also a lot of times we use the term evaporation, and evaporation is specific to water, but vaporization is just moving from liquid to gas, okay? How about condensation? Gas to liquid. That's right. Condensation is gas to liquid. Gas to liquid. Condensation. Okay. How about sublimation? Do y'all remember? Solid to gas. Right. And what's our best example of that? Everybody knows. Dry ice, right? You take the dry ice, it's solid and it makes this gaseous foam, right? This kind of smoke, right? So yeah, that's sublimation. So be aware of all of those phase changes. They will be on your quiz on Friday. Okay? All right. We have one more that I didn't mention. It's one of the least known, okay? And it's going from gas to solid. Do you see it? Deposition. From gas to solid, deposition. Sorry, when I exported this into Notebook to record it, the graphics got a little missized. Apologize. Okay, so make sure that you know this graphic. Ooh. Well, that was weird. Okay, so in terms of heat, let's talk about what happens, okay? In order to have a phase change, what must you have? Energy, right? And in most cases, it's going to be energy in the form of heat, right? So when you go from an ice to a liquid or ice to water, you have what kind of energy? Absorbed or released? Absorbed, right? Because those particles have to take in that energy in order to separate, right? When you go from water to ice, what happens to the energy? It's released because those particles have to slow down so that energy is given off, okay? So when you go from like gas to a liquid, energy is going to be released. But when you go from a liquid to a gas, energy is going to be what? Absorbed, okay? So you got to think about, am I going from a higher energy state to a lower energy state, or a lower energy state to a higher energy state? What is going to be, or which phase is going to be the lowest energy state? Which phase is going to be the lowest energy? Solid, yeah, solid. Because although the particles are vibrating, do they change positions? No, okay? Then the next level, the next energy state would be what? Liquid, right? Because the particles move around, but they don't separate completely. Then the highest energy state would be what? Gas, because now the particles can move and they can separate. Now, if we use all four phases, what would be the highest energy state? What's higher than gas? Plasma, because plasma is charged gas, right? But for our purposes, we would go solid, liquid, and then gas. So if you're going from a lower energy state to a higher energy state, then energy is going to be absorbed. If you're going from a high energy state to a lower energy state, energy is going to be released. Yes? Okay. All right. So phase changes involve change in volume, but mass remains constant. And in order to get a phase change, you have to add or remove energy. Add or remove energy. Okay? Now, some of this should be a review because I think we do phases of matter pretty much every year, right? Till you got to 8th grade. All right, plasma. Okay? This is probably the one that we understand the least. It's a gas-like mixture with charged particles. Okay? Example would be the sun and the stars, and then fluorescent light, because what we do is we charge the particles of the fluorescence to get that fluorescent light. So we take that gas and then we add the electricity or the charge to make it a plasma, right? That's how we get the fluorescent lights. Okay? Thermal expansion. What is thermal expansion? Yeah, matter has this great property of thermal expansion, and it's really nice because it's the way thermometers work, right? When we heat it, the liquid expands, right? So it rises up. And it's also the way our roads and bridges work, right? So if we had a solid bridge and it got really hot and the matter started to expand, what would happen to the bridge? Yeah, it would crumble, right? So we have these expansion joints, right? So whenever that gets really hot and it expands, it's got that room to expand, and then when it gets colder and it contracts, right? It still has those teeth or those grooves to allow that growth of expanding and contracting, right? Now, we have older bridges that don't have these expansion joints, and what happens to them? They fall apart, they deteriorate, and then we have to replace them, right? And you probably know some bridges, especially if you go around the country or whatnot, that are experiencing this, right? That need to be replaced. The end. Are there any questions?